You're ready to get started with AWS. You fire up the console, log in, and start launching things, right? Wait. Before you jump into EC2 instances, RDS databases, or EBS volumes, you need to think about networking. Getting networking set up right from the start will save you a lot of work later on. Stay tuned for my next video where we're going to cover AWS networking fundamentals like VPCs, subnets, and more. AWS networking starts at the VPC. The VPC, or Virtual Private Cloud, defines your first network inside of AWS. Let's have a look. All right, so we're going to jump into the management console and look at our AWS account. I'm going to search for VPC in the universal search bar up here and open it up. Again, VPC stands for Virtual Private Cloud. Think of that like virtual networks. It's a software-defined network. Now, when we get inside of the VPC service area, you can see there's a whole selection of services and related services down here in the left-hand navigation. Now, we're going to look at a few of those in these videos. We're certainly not going to cover all of them because it would be a very long video with some very advanced features. We're going to focus on the fundamentals here because I want you to be able to get up and started very quickly. We have VPCs. Again, this defines a network. You have subnets. This defines the sub areas of that network. You have route tables. That defines your routing within your network and how to get from one area to another. We've got internet gateways. This is the connection point between your network and the internet. Think of that like the router that goes from your private network out to the internet. You've got DHCP option sets. So this is going to be how things that are fired up within inside of your VPC get IP addresses assigned if you want to use dynamic host control protocol. NAT gateways. So much like on premises, you have network address translation that helps you get from your internal address, maybe a 10.1 IP address, out to the internet. And the same thing happens here. NAT gateway is just a managed service that allows you to do that without spinning up and managing your own NAT instances. Peering connections. This is the simplest way to connect two VPCs together to form a network that spans multiple different areas. Maybe different accounts, maybe different regions. Security. There's network address control lists and security groups. We're going to talk quite a bit about security groups in this video. We'll probably leave NACLs for a bit later. That's a little bit more of an advanced option there. Firewall instances, things of that nature. A lot of this stuff here that you can see that I'm scrolling through, these are more advanced features. We won't get to these in the fundamental video here. Because again, we want you to get set up and running. Now, when you set up a new AWS account, in each region, you get something called the default VPC set up automatically. Let's have a quick look. You can see here inside of the AWS console and in your VPCs, here is the default VPC that was set up for me. And it's got a CIDR block of 172.31. And you can see here it's got some subnets set up. This VPC is set up and ready to go. And it can be used for if you just want to click around and try something really quick. A bunch of services look for the default VPC to launch things as its default launching point. If what you want to do is just quickly play around and have a look at something, the default VPC is okay. I recommend against using it for anything that you're going to keep around because you probably will not want this CIDR address block mapping into your overall network structure. Okay, so let's start talking about custom VPCs. The custom VPC is where you're going to start building any kind of network that's going to stick around for a while. This is where you start launching your permanent resources. Now, because this is going to be a permanent fixture of your overall cloud strategy, it does require some planning. The first step in understanding how to properly set up your VPC is understanding how regions and availability zones are set up. Understanding this will help you understand why we're going to build out the VPC the way we do. Okay, so you have a region. This is this outside blue box here, such as US East 1, US West 2, etc. Regions are built all over the world. Each of these regions is made up of something called availability zones. Now, when AWS creates a region, there are at least 2 availability zones set up, usually 3, sometimes more. Each AZ is comprised of 1 or more data centers. However, the number of data centers for a particular AZ is completely hidden from you. You can't address an individual data center. So you would want to think of it like you would want to think of availability zones and data centers as being almost synonymous. Just understand that they're not. When it comes to considering things like high availability, like I said, if you consider each AZ as a separate data center, you can start spreading your applications and your network across multiple availability zones. Whereas on premises, you would design high availability or disaster recovery. You'd put an application in one data center, maybe at one side of town, and maybe another side of town or another city. Given this, we want to design a network topography that will span multiple AZs. This gives us the ability to spread our application wide and maintain high availability. As you can see here, we're going to create a VPC that exists in a single region, because VPCs can only exist in a single region. However, it's going to span 3 availability zones. I always recommend 3 availability zones when you're setting up your network. You can go more. That's perfectly fine if your high availability needs require it. However, I would always recommend at least 3 availability zones. Why is that? Well, as you can see here, we're going to create a VPC that exists in a single region, because VPCs can only exist in a single region. However, it's going to span 3 availability zones. I always recommend 3 availability zones when you're setting up your network. You can go more. That's perfectly fine if your high availability needs require it. However, I would always recommend at least 3 availability zones. Why is that? Well, imagine that there's an issue that an entire availability zone becomes unavailable for some reason. It might be a network carrier outage or something happens. If your VPC is spanning 3 availability zones, like the one we're designing here, you still have 2 left. It means your application is still highly available. If we had only spanned 2 availability zones and one goes offline, now we've only got 1 set of functionality running. So with the third, it still preserves high availability even during an outage. Now, your VPC needs to have a CIDR block established when you create it. You can see here, I've selected a 10.51/16 as my CIDR block. This is important because the CIDR block of a VPC cannot be changed once you've created it. If you make a mistake, your only choice is to delete the VPC along with any resources that have been created inside of it and then recreate everything from scratch. So plan your address space carefully. When you're designing a network on premises, you usually have limitations that are created by physical aspects of the network. Based on this, I may segment up my IP addresses by the floor or the building. Maybe I'm segmenting along an entire campus or a metro area. But my point is there's probably going to be some physical or geographic element to your strategy. And usually the more I try and segment out the network, the greater the cost because of hardware. However, when you're building networks inside of AWS, there's no such limitations. Routers and switches are non-existent. Cable distance limitations don't exist. You can have as many networks as you like. And best of all, they don't actually cost you anything. Now, some network services, such as the NAT gateway, do have costs associated with them. However, that cost is based on usage. So having more of them doesn't actually cost you anything. Unless you do something like misconfigure a NAT gateway to send traffic through multiple gateways. Yeah, don't do that. Now, some services do have limits. For example, by default, you can only have 5 VPCs set up per region per account. This is adjustable. But also, if you've watched my video on landing zones, it's one of the reasons that most organizations start spanning multiple AWS accounts. With multiple AWS accounts under your organization, the number of networks you can have is virtually unlimited. So in AWS, you can segment your IP address space by AWS region, and you'll have to do it by region, but you may also want to segment based on things like project or group of projects. This can allow you to have, say, all of your web servers and publicly facing functionality in one VPC, for instance, and all of your internal applications in another VPC and maintain complete separation. It's completely up to you. Do what makes sense for your organization. Now, let's say I have 3 offices for my internal network, and I have them segmented as follows. Maybe I have an office in Boston, maybe one in New York, and one in London. What I might want to do is reserve a block of address also for future expansion. Yes, what I've done is I've allocated all the way up to 10.50 as being reserved for future office expansion or whatever the case may be. Now, I know if an address is below 10.50, it's on-premises network. And if it's above 10.50, it's going to be in the cloud or in AWS. Now, there are people who are much better at IP address segmentation than I am, and they may have different ideas about how exactly you should segment your IP address space best. But the premise still stands. You want to have IP addresses that are reserved for on-premises networks, and you want to have sets of IP address space that is reserved for AWS. And you want to make sure that the two do not overlap. Any VPC that has any chance of connecting back to your internal network needs to be defined within this reserved address space. Overlapping IP address space is a nightmare waiting to happen, so just don't do it. The only exception to that non-overlapping IP address space is things like sandboxes accounts that would never connect to any other network. With those, you can do whatever you want to. Well, except for connecting them back to other VPCs. With this in mind, let's jump back to our network structure. The next thing we want to do is start cutting up the IP space within the VPC into subnets. Now, most customers I've dealt with will segment each availability zone into either 2 or 3 levels. You can see those pictured here on in the video. The topmost layer, or the public subnet, will be the smallest and only contain things that are safe to be exposed to the internet. In practice, this means things like load balancers. Even your web servers should not be put into the public subnets. Your private subnets is where all the real functionality goes. Now, some customers want one private subnet for all of their servers. Other customers will break it up into 2 or 3 or 4 or any number of private subnets. For example, they might want to put databases into one. They might want to have application servers in one. They might want to have web servers in another. It's up to you. You can go as deep as you want. Just make sure that for any given network, you follow the same strategy across all of the AZs. So as you can see here, I've broken the address space up into a 3x2 configuration. So 3 availability zones, 2 levels deep. And I've set up CIDR blocks for each of these. So you can see 10.51.1.0, 10.51.2, 10.51.3, and then down here I've made a jump to 10.51.128, 129, and 130. So they're all designed in a very laid out fashion. The next question I commonly get asked is, what exactly is it that makes a subnet public or private? The answer is the routing table. If your subnet has a routing table that connects it to an internet gateway, it's public. If it doesn't, then it's private. It's that simple. Now, for each level in your structure, you're going to have a routing table. Each subnet is attached to a specific routing table. We get one routing table that's our default routing table, and that's going to generally be for the public subnets. All of them will share the same routing table. You'll then get a routing table for your private subnets. Now, it's quite often you're going to see one routing table for each of the private subnets individually. Your private routing table is going to have a default address, so the 0.0.0.0 address that goes to a NAT gateway. This allows your private instances to still be able to reach the internet for things like patching, but makes it so they can't be accessed directly from the internet. So now that we have a network diagram ready, we can jump into the console and start building out our network with confidence. Now, if this diagram seems a little bit complicated, don't worry. AWS has provided a networking wizard that, now that we understand how our network should be laid out, the wizard will do all of the implementation work for us. Makes it super easy. All right, so here we are back in the AWS console, and we're going to go to creating a VPC. So in the default search, I can go VPC and select the service. Once again, you can see here, this is the default VPC that's created. I'm just going to leave that alone because, as I mentioned, some things actually expect that default VPC to be there. And if it's not, you can kind of make it a little bit more difficult to spin up certain resources. So I'm just going to leave it there and ignore it for the moment. What I can do here is I can go to this Create VPC button. And this is going to walk us through a launch wizard that AWS has created. Now, it used to be that this was very limited in what it could do, but there's been a lot of really nice extensions to this. First thing you've got here is a choice. It says, are we creating a VPC only or a VPC and more? So the and more is going to be things like subnets and internet gateways and NAT gateways and things of that nature, which is really what we want to do here. So I'm going to click here to VPC and more. You can see that the wizard has changed, and we've also got a preview. And this is really nice because it'll start showing us what things are actually getting set up and where. Okay, so first we have a tag name. So, everything needs a name. I'm going to give this demo VPC there. And you can see that not only is the VPC getting a name, getting that name attached to it, but we're also starting to see all the other resources inheriting that name. Again, this makes it really nice because we can go back into the console a little bit later on and we can see where those resources are. Now our VPC is going to get a CIDR block. Okay, now by default it's 10.0. If I look back at our diagram, what we were actually setting this up with was 10.51.0.0/16. And we can see that CIDR block is between a 16 and a 28, and this is going to allocate 65,000 IP addresses for this entire network. Should be fine. I shouldn't run out of those in my demo network. You then have the option here whether or not you want to create an IPv6 CIDR block or not. I'm not going to do this at the moment. We're really just talking about AWS fundamentals. I don't want to dive into a whole lot of complexities here. And tenancy being default. You've got default tenancy or dedicated tenancy. In almost every case, you're going to stick with default tenancy. Now we've got the number of availability zones. Now, if I look back at our diagram, we were talking about 3 availability zones. So I'm going to switch that over to 3, and you can see once again, my structure has been updated here. And customize AZs. I've got the option of specifying which availability zones that I want to include in my network. I'm just going to include A, B, and C. If you had more or you had a preference to move away from A, B, and C, you certainly could. In this case, I'm in Northern Virginia, and you can see here there are A, B, C, D, E, and F available. So there's 1, 2, 3, 4, 6 different availability zones. I'm going to leave those exactly as is. We now have a reference for the number of public subnets. So again, you want to have 1 public subnet per AZ if you're going to have any public subnets at all. So you can see there I have the option of 0 or 3. I'm going to leave it as 3. And now the number of private subnets. Now once again, you've got the very common options of having 1 private subnet per AZ or 2 private subnets per AZ. I'm going to stick with 1 because it's just going to make things a little bit simpler, but the wizard can handle having 2. So that makes it, again, very easy if you want to be able to manage those and extend your network. Again, maybe you want to have web servers in one subnet, and you might want to have database servers in another. Again, we've got the option here to drop down and customize our CIDR blocks. And it's going to helpfully label out public subnet in US East 1A, 1B, 1C, and then private CIDR blocks. So what I had done in my diagram, and I just want things to match, I had said 1 / 24 it's at 2 / 24 and 3 / 24. And now for my private ones, I've got 128.0 / 24, 129, 4, 130, 4. Oops. So this now matches my diagram. Each one of these has got 256 IP addresses. So we've got 10.51, 1, 2, 3, and 128, 129, and 30. And if you flip back to the diagram, that's exactly what it is. You now have to decide what you want to do for NAT gateways. Now, you can have no NAT gateways, in which case you've got no ability for natting your traffic out from those private subnets out through to the internet. If you still want to have network connectivity, in this case, where there's none selected, you would have to set up a NAT instance. So it's a EC2 instance that is set up to run as your own NAT gateway. You can set up 1 in 1 AZ, or you can set up 1 per AZ. Now, I'm only going to set up 1 in 1 AZ. Understand that a NAT gateway as a managed service is highly available within the AZ that it is configured. So if you really want very good high availability, you should actually go with 1 per AZ. I'm going to leave it on 1 for cost and simplicity's sake. It's not going to be a big deal for my demo environment. And in practice, it's probably not a big deal for most customers. In the event an entire AZ went down and it happened to be the one that my NAT gateway is in, then I would have some difficulties. Okay. The next thing you have is the option to automatically set up VPC endpoints. So this is endpoints that are created and attached to your VPC that allow you to have traffic that goes directly to a service without going out through the internet. There's a bunch of services that support it. One of the most common ones is Amazon S3. I'm going to turn this off for now because I don't really anticipate needing it, but just be aware that you can have it set up. You then have your DNS options, so you can enable host names and enable DNS resolution. For the most part, you'd want to leave these enabled. And then additional tags. So if your organization enforces a tagging policy, you might want to put tags in there that reference maybe cost centers or things of that nature. Tags are very helpful for that management facility. Now, if we look over here, I'm going to scroll over, this gets really nice because we've got the VPC and you can see everything that's attached to it, but you can start seeing the flows. So my public subnet goes here, it goes to the public routing table, which goes out to the internet gateway. The same with my public subnet here in B, my public subnet in C, and then you can see that there are routes through from my private subnets through to routing tables for the private subnets, and then to the net gateway. So right away, before I hit create, I can actually see my network and what it's going to look like here. So I can say, oh, wait, maybe I want to make some changes before I hit the button. Now I'm happy with how this looks, so I'm going to go and hit create VPC. Now, you can see there's going to be a whole bunch of different things going, and there's actually a really nice flow. This is going to take a few seconds to complete. So I'm going to pause the video and come back when it's done. Okay, here we are back again, and you can see the VPC is finished creating, and all of these resources have been created for us. And you look around here and you can see the VPC, the hostname resolution, the subnets have been created for us, the internet gateway has been attached, we've got route tables, routes, and everything is done for us. So what we're going to do here is just click this View VPC, and this is going to throw us back into the main VPC area, and you can start seeing all of the functionality that is set up and created and ready to go for us. And once again, we've got the pieces all showing up, so we can actually see what's going on. We can see the CIDR blocks that are allocated. And if we jump into here, say subnets, we can actually see the subnets that were created for us. The route tables, you can see demo PC route tables, internet gateway. So it is all set up and ready to go for us. And it was very easy. Once we planned it out, and the biggest allotment of time was really in setting out that plan. So plan, and then the creation goes really easy. Okay, one last topic to cover quickly. Let's talk about using your VPC. Now, as I mentioned, we have a public and private set of subnets across 3 availability zones. Let's set up a web server so you can see how these things start to play together. And we're going to do that now by jumping into the AWS console. Okay, I'm here once again in the AWS console, and since I'm going to start up a web server, I'm going to click EC2. And you can see I have no instances running. I'm going to launch an instance. I'm going to give it a name. And here I'm going to select my AMIs, owned by me. I've got this web test image that I've created for another project, and it basically just runs a very simple web application that I created. So I'm going to click there, web test image, instance type, T2 micro is perfectly fine. I'm going to skip the key pair because I'm not going to let this running for very long. All right, network settings. I'm going to come here and click edit. And I'm going to choose my demo VPC. And now subnet. You can see all the subnets that were created as part of my VPC setup. I don't want public. I want private. So I'm going to choose demo VPC subnet private 2. Okay, auto assign public IP. I'm actually going to click, normally I would leave this disabled, but I'm going to click enabled so that we can see the difference in the public and the private subnet and what happens there. The next thing I need to do is I need to create a security group. Now, if I already had one designed, then I could use that. But since this is a brand new VPC, I don't have security groups set up. So I'm going to give it a name. Demo security group. And now I'm going to define the inbound security group rules. By default, we're allowing RDP access. You should never do this. You should never allow public RDP access into your instances. There's always much better ways to do that. So I'm going to remove those rules. I'm going to add a security group rule. I'm going to allow HTTP 480. The source, I'm going to allow that from anywhere because it's a web server. That should be fine. Public key. And I'm going to allow HTTPS again from anywhere. Those two should be fairly simple. And at the end of the day, I'm going to delete this as soon as I finish this video as well. Now, always a good idea, give your security group a name that is something you're going to remember. Don't use the default name that says something like Launch Wizard configuration. You're going to have dozens of those things piled up before you know it, and you're not going to be able to tell which one's used for which. So give it a name. Again, demo security group. I think these actually have to be lowercase. Security group rules, storage. I'm going to leave that all default. We can see here the summary. And it says free tier available. That's great. If you have a new account for the first year, you get the free tier. In this case, I shouldn't actually see anything. And I'm going to hit launch instance. Okay, now this is going to take a little while. Well, the instance gets created fairly quickly, but you can see here it's going to take a little bit of time to fully get up and running. I'm going to pause the video once again, and then we'll connect back in. Okay, a few minutes has passed, and you can see now the test web server is up and running. And you can see here it has a public IP address. However, if I try to hit that public IP address, what we're going to notice is okay, I did pause it because nobody wants to sit here and watch the internet wait to time out. As you can see here, trying to connect to that public address, even though it's up and available right there, has resulted in a connection timeout error. And that's because this instance is sitting in a private subnet. So there's no route from the public internet that I'm accessing here on my machine through to that EC2 instance. This is where public subnets and load balancers start to come in handy. Okay, so this can get a little confusing. Load balancers, even though they're a network function, are here inside of the EC2 console. So load balancers require two things. the actual load balancer, and then a target group. And that target group is where requests get routed to. So we're going to go and set those up real quick, and then you're going to see how things start working. Okay, I'm going to create a new load balancer, and I've got a couple choices here. We've got an application load balancer. This is a high-level, level 7 load balancer that's designed for routing HTTP traffic. You've got a network load balancer. This is a low-level, I think it's level 3 network load balancer designed for really high speed, low throughput. And then you've got a gateway load balancer, which is for other types of activities. There's actually a classic load balancer down here. You'd never want to use that in practice. We're going to go with creating an application load balancer. All right, basic configuration, you can give it a name, demo LB. It is going to be internet facing, so you can have a load balancer that's internet facing, or you can have an internal load balancer. In this case, obviously, we want the internal one. IP address, we're just going to use IPv4, that's fine. Now, VPC, so networking. Okay, we want to make sure we select the correct network. And this is automatically going to publish, is going to give us access to the 3 subnets that we have. And we can select the subnets where the load balance is going to exist. Now, this is an internet-facing one, so we obviously need to make sure these go into the public subnets and not the private subnets. Here we go. Security groups. I'm just going to reuse the demo security group because that allows traffic on port 80 and 443. That's perfectly fine. You can set up a separate security group for your load balancer and your EC2 instances. And what you may want to actually do that because you may want to have your EC2 instance only accept HTTP traffic from the load balancer, but the load balancer would want to accept traffic from anywhere. In this case, though, it's fine because I've just allowed HTTP and HTTPS from everywhere. Okay, now you come down here and we've got listeners and routing. So what this is going to do is say for every HTTP request that comes in on port 80, we're going to set an action. And that action is going to, the default action is going to be forward it to a target group, but we don't have any target groups set up. So I'm going to go here and create a new target group. Okay, what's the target type? This is going to be instances because I'm running EC2 instances. You could also do IP addresses if for some reason you needed to do that, or a Lambda function, or another application load balancer. Instances is fine in this. I'm going to say demo target group, HTTP, the protocol. So HTTP is the protocol and port 80. VPC, again, we got to make sure we're selecting demo VPC. Protocol, HTTP1 is fine. Health checks, we're just going to leave that as it is. Next. And we've got 2 options. Now, we can just skip allocating anything. Okay, and that would work fine if we were going to integrate this with an auto-scaling group. Or we can actually select the available instance and have that created or have that allocated as part of creating that target group. I'm going to do that now just because it's going to save us a few clicks later on. Okay. You go include as pending below. You can see it's set up there. And now I'm going to go create target group. And from there, if I go back to our application load balancer and refresh, I can see I've got a demo target group all set and ready to go there. Scroll down, bunch of other things. I'm going to leave these all default right now, and I'm going to click Create Load Balancer. There's going to be a little process. It's got to go through the provisioning step. I'm going to pause now and we'll jump back to this once it's done provisioning. Okay, a few minutes has passed and the load balancer has been created. You can see here the load balancer is now active. You can see the VPC, the availability zones, and it's all set to go. You can see here there's the default protocol routing rule, which says all port 80 traffic gets sent to that target group. And if we go back here to the target group, you can see that's set up and ready to go, and there's one instance set up there. If we have multiple, then obviously you'd see more, more instances sitting there. So if you remember, we couldn't get access directly to the EC2 instance. In fact, let's go there again. Open a new tab. The template web server that's running. Open address. Again, this is going to time out really quick. And we'll just let that go. If we come here to the load balancer, the load balancer is now sitting in that public subnet in my VPC. I can copy here, copy the DNS name. I come here. You can see the default IIS test web page that comes up. So what's happened is the request has gone in. It's hit the load balancer sitting in my public subnet. It's then passed it through into the EC2 instance that it's routed to in the private subnet. So even though I can't get to the EC2 instance directly by the IP address or by the DNS name, actually, if I looked here, we'd see the public DNS name. Again, that won't resolve either. But the load balancer sitting in that public subnet makes it accessible for us. So this is how you can set up your subnets. You can make sure you have high availability, and you can understand all of those constructs that are working together at a base level. And this has been the fundamentals. The next video I'm going to shoot on networking is going to look at VPC peering and how to make connections between two different VPCs, maybe in different regions. So tune in for that one. Complete source code for all of my videos can be found on GitHub. You can find me there at github.com/basementprogrammer. Thanks for watching my video. If you found this video helpful, please hit the subscribe button. It helps you to know when I have new content out, and it helps me to know I'm creating useful content for you. You can always find me at basementprogrammer.com, on Twitter, and the Basement Programmer podcast. Details listed here. If you have any comments on this video, or you just want to get in touch, you can always email me. The address is tom@basementprogrammer.com. And I'll see you next time.